Okay, so our production system is essentially a transformation process where we take various inputs and convert them into something more valuable. Think of it like a well orchestrated symphony where different elements come together to create something meaningful. So production is all about transformation is like a chef taking raw ingredients and turning them into a gourmet meal. In business terms, we take inputs and transform them into goods or services that have greater value. For example, when Toyota takes steel, plastic, and electronics and transform them into a car, they are creating something worth far more than the sum of its parts. So this is what we call value addition process. Let's take the example of furniture manufacturing when we take raw wood worth of $100 and transform it into a beautiful dining table that sells for about $1,000. We have added $900 of value through our production process. This added value comes from design, craftsmanship, and efficient manufacturing processes. So we see the examples of production systems everywhere in our daily lives, from the smartphone in your pocket, which started as raw materials like silicon and metals, to the computer on your desk, even the car you drive. Each of these represents the output of sophisticated production systems. So let's break down the key components of a production system. Think of it as a three-act play. First, we have the inputs, the raw materials that enter our system. These are like the ingredients a chef needs to prepare a meal. Next comes the conversion subsystem, where both humans and machines work together to transform these inputs. This is where the real magic happens, combining human skills with technological capabilities. The control subsystem ensures everything meets our quality standards like a quality inspector, making sure every product is perfect. Finally, we have our outputs, the finished products ready for customers. So, production systems are the heart of manufacturing operations worldwide. They are how businesses organize their manufacturing processes to create products efficiently and effectively. At their core, production systems are categorized based on volume and variety. It's like thinking about restaurants. Some make custom meals for each customer, while others serve thousands of identical burgers each day. In manufacturing, we have a similar spectrum. So let's start with the job shop production. This is like a custom tailor making a suit specifically for you. In a job shop, skilled workers create unique, one of a kind products. A great example would be specialized machine shop that builds custom equipment for aerospace companies or craftsmen's person making a bespoke furniture. The emphasis here is only on highly customized product with scale level and flexible equipment. Next, we have the batch production. Think of this like a bakery that makes croissant in the morning, bread at the midway, and the cakes in the afternoon. Batch production creates products in groups or batches rather than continuously. For example, a cosmetic company might produce 5,000 bottles of one perfume on Monday, then switch to 3,000 bottles of another fragrance on Tuesday. The equipment is versatile enough to be reconfigured between batches. Then there's a mass production. So this is like a hamburger chain that makes thousands of identical burgers every day. Mass production focuses on high volumes of standardized products. The classic example is automobile assembly line, where identical operations are repeated over and over. Workers become highly specialized and the equipment is designed for one specific purpose. While it costs a lot to set up initially, the cost per unit becomes very low when production in large volumes. The fourth type is continuous production. Imagine an oil refinery that runs 24/7, processing crude oil into gasoline without ever stopping. Continuous production systems operate around the clock, producing the same product without interruption. Other examples include paper mills, chemical plants, and electricity generation. These facilities involve highly automated processes with minimal human intervention, designed specifically for one product or a narrow range of similar products. So now let's talk about another important distinction between the discrete versus continuous production. It's like comparing making cookies versus making ketchups. One creates countable items, the other creates a flowing stream of products. So, discrete production systems create individual items that can be counted as separate units. Think about electronics assembly, furniture manufacturing, or automobile production. The factory might regularly change setups to accommodate different products or models. Your smartphone was made in a discrete production system as a distinct unit moving through various stages of assembly. So, in contrast, continuous production systems produce items that flow continuously like a river. Think about petroleum refineries, chemical plants, or breweries. The production process doesn't create individual units but rather a continuous stream of products. The same product is typically produced 24/7 with minimal interruptions, and the entire facility is optimized for this specific purpose. So understanding these different production systems help business choose the most appropriate approach based on their products, their market, and their business strategy. A furniture maker might use batch production for standard pieces, but job shop methods for custom orders. A petroleum company would obviously use continuous production for refining. Each system has its own advantages and applications in modern manufacturing. So remember, the most successful companies often select the right production system for their specific needs and they continually refine it to maximize efficiency and the value creation. So let's explore the job shop production, one of the most versatile manufacturing approaches in modern industry. Job shop production is essentially small-scale manufacturing where products are customized according to specific customer requirements. It's like having a personal chef who prepares exactly what you want, exactly how you want it. So the most striking feature of job shops production is its use of general-purpose machine and flexible layouts. Unlike mass production facility with rigid assembly lines, job shops arrange equipment by function. Picture a workshop where cutting machines are grouped in one area, assemble stations in another, and finishing equipment in a third. This allows different products to follow different paths throughout the facilities based on what they need. So job shops thrive on variety. Walking through a job shop, you might see workers crafting a custom motorcycle frame, specialized specific equipment, and the bespoke furniture all on the same day. This is completely different from mass production, where thousands of identical items are made. In a job shop, you will find high product variety but low volume, sometimes producing just one unit of a particular design. So the backbone of any successful job shop is a skilled workforce. They are not just workers performing same repetitive tasks all day. They are more like artisans who understand their entire craft from start to finish. A metal worker in a job shop doesn't just operate a single machine. They can read complex blueprints, make adjustments on the fly, and apply their expertise to solve unique manufacturing challenges. This comprehensive knowledge allows them to create truly customized products. One characteristic you will notice in job shop is higher level of in-process inventory. Since each product might follow a different path through the workshop and require different processing times, you will often see a partially completed product waiting for the next operation. Look at customer furniture shop and you will see various pieces in different stages of completion. Some being sanded, others waiting for staining, and others being assembled. So finally, the cost structure of job shops. So reflects their customized nature without the economies of scale that come with the making thousands of identical items. Each product bears the full cost of design, setup, and specialized work. Additionally, the skilled labor record commands higher wages than assembly line workers. Think about tailor suit versus one off the rack. The custom version costs more but provides exactly what the customer wants. Job shop production continues to thrive in today's manufacturing landscape, particularly for specialized high value products where customization matters more than price. From aerospace components to artistic metalworks, architectural millwork to prototype development, job shops create the unique products that standard factories simply cannot produce. So in this slide, let's examine why many manufacturers choose job shop production despite its challenges. So job shop production offers several unique advantages that make it invaluable for certain manufacturing scenarios. Think of it as having a swift army knife instead of a single purpose tool, less efficient for any one task but incredibly versatile overall. So the most obvious advantages is job shop production's perfect suitability or for custom product manufacturing. When customers need products built to their exact specifications, job shop shines. Imagine an aerospace company that needs just five specialized testing devices. Not enough to justify mass production, but perfect for a job shop. Or consider a wealthy homeowner who wants unique handcraft furniture that matches their specific design vision. Job shops can take these special requests and turn them into reality, something that will be impossible in a mass production environment. So job shop creates an environment that naturally encourages skill and development and innovation. So unlike assembly line workers who might perform the same tasks thousands of times, job shop employees constantly face new challenges. A metal worker might fabricate a complex aerospace components on Monday and designing a custom machine part on Tuesday. So this variety pushes workers to continually expand their skills and find creative solutions to unique problems. Think about how a master chef develops expertise by cooking many different dishes rather than making same meal repeatedly. So job shops foster this kind of growth and creativity. So this lead to another significant advantage. Job shops maximize worker potential. Employees in job shops typically use a wide range of skills and are involved in multiple aspects of production. They often see projects through from concept to completion. So giving them a sense of ownership and their pride in their work, this comprehensive involvement tends to increase job satisfaction to attract and attract highly skilled workers who value craftsmanship and variety. It's a difference between the being an artist creating a unique pieces versus being a cog in the production line. So, however, job shop production is not without its challenges. The customized nature of the work brings both high costs and high inventory levels without the economies of scale that come with making thousands of identical items. Each product bears the full cost of design, setup, and specialized work. So additionally, since the different products follow different paths through the workshop, you will often see partially completed items waiting for their next operation, tying up capital in progress inventory. So these factors make job shop products more expensive than mass produced alternatives. So another challenge lies in production planning, which becomes remarkably complex in a job shop environment. Scheduling different products with different requirements through the same equipment requires sophisticated planning. So imagine an air traffic controller managing planes with different origins, destinations, and requirements. Job shop scheduling represent a similar complexity. Each new order might requiring a completely different production path, making it difficult to establish smooth, predictable workflows. So job shop also often struggle with unnecessary movement of workers and materials because equipment is typically organized by function rather than product flow. Items might zigzag across the facility during the production. So workers frequently need to transport materials between workstations, leading to inefficiency. Picture a kitchen where the refrigerator, stove, and the cutting board are in different rooms. The chef would waste time moving between them. Similarly, job shops sometimes create insufficient movements that wouldn't exist in a dedicated production line. So despite these challenges, job shop production remains essential in our manufacturing ecosystem. For specialized custom or low volume products, the flexibility and craftsmanship of job shops simply cannot be matched by the mass production techniques. By understanding both the advantages and the limitations of the job shop production, manufacturers can make informed decisions about when this approach makes the most sense of their specific needs. Okay, now let's explore batch production, a versatile manufacturing approach that sits between custom job shops and mass production. Batch production is likely a bakery that makes several dozens identical loaves of bread, then switches to making pastries and later shifts to cakes. Is manufacturing items a distinct group of batches, often producing them in anticipation of sales rather than waiting for specific customer orders. So what makes batch production unique is how it balances customization with efficiency. Unlike job shops that might make just one custom item, batch production creates multiple identical units at once, perhaps dozens or hundreds. But unlike mass production, which might make thousands or millions of the same item continuously, batch production runs are relatively short. For example, a clothing manufacturer might produce 500 blue shirts this week, then switch to 300 red dresses next week, allowing them to maintain variety while still achieving some economies of scale. So flexibility is a hallmark of batch production. The manufacturing setup can be reconfigured between different product runs. Think about a commercial kitchen that uses the same oven workspace to prepare different menus items throughout the day. Similarly, batch production facilities can adjust their equipment and processes to handle different products. This adaptability allows manufacturers to respond changing market demands without massive investment in dedicated production lines. So production typically employs semi-automatic machines rather than fully manual or fully automated equipment. These machines strike a balance. They are more efficient than the general purpose of equipment found in job shops, but more versatile than the specialized automation used in mass production. Picture a bottling line that can be adjusted to fit different size containers with different products. Workers operate these machines and make the necessary adjustments. Um, when switching between batches. This approach combines the efficiency of automation with the flexibility of human oversight. So one key advantage of batch production is lower production cost compared to job shop manufacturing. By producing multiple identical items in each run, manufacturers can spread setup across costs across more units. Think about how it's more efficient to bake a dozen of cookies at once rather than one at a time. Each cookie costs less to produce when made in batch. Similarly, making 200 identical components at once is more economic than making each one individually. Even though the equipment might need reconfiguration for the next product run. So the physical layout of batch production facilities typically groups machines by function rather than creating a single production line. You might find all cutting machines in one area, forming machines in another, and finishing equipment in a third. This functional grouping allows different products to follow different paths throughout the facility depending on what processes they require. It's like having stations in a kitchen, mixing, baking, decorating that can be used different sequences for different recipes. Okay, so the batch production creates a distinct workflow patterns. Materials move through our facilities in groups with each batch being processed completely at one workstation before moving to the next. This creates a stop and a go pattern rather than the continuous flow seen in the mass production. You will often notice partially completed batches waiting at the various stages of production. This work in progress inventory is a natural part of batch manufacturing as different products queue up for their run at each processing station. So the industries that frequently use batch production include pharmaceutical, specialty food, printing, clothing, manufacturing, and furniture making. These sectors need the flexibility to produce different products while still maintaining reasonable costs. A furniture manufacturer might make 15 oak dining tables one week, then another week 30 walnut bookshelves maybe the next, achieving better efficiency than custom making each price individually. So batch production represents an important middle ground in manufacturing strategy, more flexible than mass production, but most more efficient than chop shops. By understanding when to apply batch techniques, manufacturers can balance the competing demand of cost, customization, and production volume to the best serve their specific markets. So let's explore why many manufacturers choose batch production and what challenges they face when implementing this approach. Batch production offers a unique balance of efficiency and the flexibility that makes it ideal for certain manufacturing scenarios. Think of it as having the versatility to make different dishes in a restaurant kitchen while still being more efficient than cooking individual meals to order. So one of the major advantages of batch production is the better utilizations of machines and equipment. Unlike job shops where machines might sit idle between custom orders, batch production keeps equipment working more consistently. Imagine a printing company that runs its presses for complete batches of business cards, then brochures, then posters. Then the process stay busy throughout the day, maximizing the return on the expensive equipment. By producing it batches, manufacturer can keep their machines running for longer periods, spreading the fixed costs across more products. So this improved equipment utilization leads directly to another key advantages, lower cost per unit compared to job shop production. When you produce items in batches rather than individually, you can spread setup costs across multiple units. Consider a bakery that needs to prepare ingredients, heat the oven, clean up afterward. Making 20 loaves of bread at once is far more economical than making each loaf individually with separate setup each time. So similarly, in manufacturing, the cost of setting up machines, programming systems, and arranging materials can be distributed across all the items in a batch, reducing the cost per unit significantly. Perhaps the most valuable advantage of batch production is its flexibility to produce different products. Unlike mass production lines that are designed to make just one product continuously, batch production facility can switch between different items. A cosmetic manufacturer might produce shampoo on Monday and conditioner on Tuesday and body wash on Wednesday, all using much of the same equipment but reconfigure between the batches. This adaptability allowed companies to offer product variety without investing in separate production lines for each item. It's like a chef who can use same kitchen to prepare different menus items throughout the day. So, however, the batch production does come with certain limitations that manufacturers must manage. One significant challenge is complex material handling requirements. Because different products follow different paths through the facility, moving materials and partially completed batches become complicated. Picture a kitchen where ingredients need to be transported between separate stations for different recipes. There's considerable movement and coordination required. In batch production, products often zigzag through the facility rather than following a straight line, creating logistical challenges and potentially increasing handling costs. So production planning becomes particularly different in a batch environment. Scheduling different products through the same equipment while minimizing downtime between batches requires sophisticated planning. Managers must decide which products to make in what quantities and in sequence to optimize efficiency. It's like solving a complex puzzle where each decision affects multiple other factors. If one batch takes longer than expected, it can be disrupt the entire production schedule. This completely makes production planning in batch manufacturing much more challenging than in most straightforward production approaches. So another limitation of batch production is higher work in process inventory since the sales items move through production in batches rather than continuously. Partially completed batches often wait at various stages before moving to the next operation. This creates pools of inventory throughout the facility. Think about a restaurant where batches of partially prepared ingredients waiting for the next cooking stages. These inventory accumulations tie up capital and space that could otherwise be used more productivity. The larger the batches, the more complex production process, the more significant this inventory challenge becomes. So despite these limitations, batch production remains an essential manufacturing approach for many industries. It serves as a middle ground between highly customized job shops and rigid mass production lines. Companies that need product variety while still achieving reasonable economy of scale often find batch production to be the most viable option. By understanding both the advantages and the limitation of the approach, manufacturers can implement batch production effectively and develop strategies to minimize its inherent challenges. Let's explore mass production, a manufacturing approach that transforms our modern world. So, mass production is essentially large volume manufacturing of standardized product. Items are identical in design and function. Think about how your smartphone, your car, or even something as simple as ballpoint pen is made exactly the same way as the thousands or millions of others just like it. This standardization is the foundation of mass production, pioneered by Henry Ford, who famously implemented it for automobile production, dramatically reducing the time to build a car from 12 hours to just 93 minutes. So what truly defines mass production is its focus on standardized products and processes. Every item coming off a mass production line is virtually identical to the ones before and after it. This standardization extends to the manufacturing process itself. The same steps are followed in the same order over and over again. Imagine a fast food restaurant where every burger is made exactly the same way following precise procedures. Mass production works on this principle, but with even greater precision and consistency. This standardization allows for remarkable efficiency, quality control, and ultimately transform how we make things. Instead of craftsmen building entire products individually, mass production divides work into specialized tasks performed repeatedly by workers or machines. Mass production relies heavily on special purpose high-speed machines designed to perform specific tasks extremely efficiently. Unlike the general purpose equipment found in general job shops or batch production, these machines are optimized to perform one operation perfectly, thousand or million times. Think about an automated bottling machine that can fill cap and level 500 bottles per minute, or stamping press that forms cardboard panels in seconds. These specialized machines require significant upfront investment but deliver exceptional productivity of their specific purpose. They are like Olympic athletes who have trained to excel at just one event rather than being good at many multiple different sports. The economic impact of these machines is profound. They dramatically reduce the cost of goods, making products affordable to far more people than was previously possible. So the hallmark of mass production is high production volume combined with lower cycle time. So cycle time refers how long it takes to complete one unit of a product. In mass production, this time is minimized through specialized equipment, streamlined processes, and worker specialization. An electronic assembly line might produce thousands of identical circuit boards every day, with each board taking just minutes to complete. The speed and scale are what make mass production so economically powerful. Fixed costs like equipment and facilities are spread across enormous quantities of products, making each individual unit less expensive to produce. Mass production continues to evolve in modern era, incorporating automation, robotics, and computer control systems to further reduce cycles. So another defining characteristics of a mass production is continuous material flow. Unlike batch production where materials move in groups or job shops where each product follows a unique path, mass production creates a steady uninterrupted flow of materials through the factory. Picture a river flowing smoothly from one point to another. In an automobile assembly plant, car frames move steadily along a conveyor system with components being added at each station until the finished vehicle emerges at the end. This continuous flow minimizes waiting time and work-in-process inventory, further enhancing efficiency. Mass production typically utilizes a linear layout where workstations are arranged in the sequence of operations required to make the product. This arrangement minimizes transportation within the facility and creates visual management system where problems become immediately apparent if the flow stops. Okay, let's examine why mass production became so dominant in manufacturing and why trade-offs is involved. Mass production offers powerful advantages that revolutionized industry, but it also comes with significant limitations that manufacturers must carefully consider. Think of it as a manufacturing approach that excels at making identical products efficiently but struggles when variation is needed. So, one of the most striking advantages of mass production is its remarkably high production rate. Mass production lines can create products at speeds that would be impossible with other manufacturing approaches. An automobile assembly line might produce a completed car every minute, while a beverage bottling facility can fill thousands of containers per hour. This extraordinary output comes from the combination of specialized equipment, standardized processes, and continuous flow. The production line never stops, it keeps moving steadily, creating a constant stream of finished products. This relentless productivity is what allows mass producers to meet the enormous demand for consumer goods in our modern world. So mass production systems require large-scale workers compared to other manufacturing approaches because tasks are broken down into simple, repetitive operations. Workers don't need years of training to perform their specific roles effectively. Compare this to a skillcraft person who might need a decade to master all the aspects of creating a product. In mass production, a worker might learn their specific tasks in days or weeks rather than years. This simplification of work was revolutionary. It allowed manufacturers to expand rapidly without being limited by the availability of highly skilled workers. A new employee on an assembly line can become productive much faster than an apprentice in a traditional craft shop. Another significant advantage is the lower overall manpower requirement. The combination of specialized machinery and efficient processes dramatically reduces the total labor needed to produce each unit. An automated beverage bottling line, might need just a handful of operators to produce millions of bottles per day. This efficiency comes from replacing human labor with mechanical and automated systems whenever possible. Tasks that might require dozens of workers in less efficient systems can be accomplished with just a few mass production. This reduces labor requirement not only lower cost but all allows production to continue even when the skilled labor is scarce. So perhaps the most transformative advantages of mass production is the dramatically lower unit cost it achieves by spreading fixed costs like equipment, facilities, and development across millions of units. The cost per item plummets. Think about how affordable everyday items have become. Products that would have been luxury a century ago are now accessible to almost everyone. This cost reduction comes from the multiple factors: economy of scale in purchasing materials, efficient use of expensive equipment, reduced labor costs, and standardized processes that minimize waste. This economic impact has been profound. Mass production has made consumer goods affordable for the masses, dramatically rising living standards worldwide. However, mass production comes with the significant limitations that manufacturers must manage. The most obvious is its lack of flexibility and product variation. Mass production systems are designed to make identical product over and over again. Making changes to the product often require costly and time-consuming modifications to equipment, processes, and training. Imagine a factory that makes blue pants suddenly needing to produce red pants. What seems like a simple change might require adjustment throughout the production line. This rigidity means mass producers struggle to respond quickly to the changing consumer preferences or to offer the variety that some markets demand. So another major limitation is the very high investment required. Setting up a mass production facility involves enormous capital expenditure on specialized equipment, dedicated facilities, and extensive planning. A modern automobile assembly plant might cost billions of dollars to build and equip before producing a single car. This massive upfront cost creates significant financial risks. If the product doesn't sell as expected, recovering this investment becomes challenging. It also creates a barrier to entry that prevents smaller companies from competing in industry dominated by the mass production. Only companies with substantial financial resources can typically afford to establish true mass production operations. Mass production also struggles with limited product differentiation when every item coming offline is identical. It becomes difficult to serve markets that value uniqueness or customization. This limitation becomes increasingly significant as consumer preference shift towards personalized products. Think about how people often pay premium prices for handcraft or customized items that expresses their individuality. Mass producers typically can offer this level of differentiation without fundamentally changing their manufacturing approach. This limitation has led many mass producers to seek ways of introducing some degree of customization while still maintaining the efficiency of their production systems, a challenging balance to achieve. So, as we conclude, let's highlight the essential concept about production system that we have explored today. So, production is fundamentally a value addition process. When manufacturers transform raw materials into finished products, they create additional value at each step. A furniture maker takes wood worth of $100 and creates a table worth of $1,000, adding $900 in value through design and craftsmanship. This concept applies across all manufacturing. The goal always create output worth more than the sum of its inputs. We have examined four major production systems in manufacturing. Job shop production creates customized products with skilled workers. Batch production makes products in groups, like bakery making different pastries throughout the day. Mass production manufactures standardized products in high volumes like cars on an assembly line. Continuous production operates 24/7 without interruption like wire refinery or paper mills. Each system suits different manufacturing needs based on volume and variety and market requirements. The future of manufacturing shows a clear trend toward automation and lean principles. Modern factories use robust and automated systems for precision and consistency. Lean manufacturing eliminates waste in all forms of, wasted time, materials, movement, inventory, and so on. Together, these approaches are creating more efficient and responsive production systems that will continue to evolve with advancing technology.